I welcome you back to Mwalimu Education Services, and we are going to start from where we stopped. Let me share my screen so that we continue with our nuclear chemistry. So basically, we had looked at, we had covered radiations and radioactive decay. If you recall, if I may take you back slightly, let me increase my screen a little bit. If I may take you back slightly, we saw that radioactivity is the spontaneous disintegration of the nucleus of a heavier atom to form simpler stable nuclei. But the process is accompanied by emission of radiations. So during radioactivity, we have something huge breaking it down to give us something which is small and stable. However, when that process of breaking down occurs, radiations are emitted. And these radiations that are emitted are known as radioactive particles. Radioactive particles. Radioactive particles that are emitted, we have alpha particles, we have beta particles, and gamma rays. So we are going to explore what each of these particles represent as in their nature and also their properties. So we have a simple table here. Don't forget, I told you last time, you can decide first, pause, then write down this work, and then later on listen to the explanation. Or alternatively, you can decide to first listen to my explanation. Then after listening, you pause and write down the work. So we have this table that summarizes the nature of the particles that are emitted during radioactive decay. So this is the first column shows the property of each radiations, and the radiations are, we have alpha rays, alpha particles, we have beta particles, then we also have gamma particles. So we start with the nature. What are these particles? What do we mean by alpha particle, beta particle, and gamma rays? So for an alpha particle here, we mean the nuclei of helium. Helium is an element of the periodic table which has this symbolic representation. So this helium, the atom of helium is what we mean by the alpha particle. So it implies that if we have a heavier unstable atom, that atom can decompose to give something which is small and stable by emitting the particle of helium. And the particle of helium is what we call the alpha particles. So alpha particles are helium nuclei with this symbolic representation. Then we also have beta rays or beta particles. Beta particles, these are high speeding electrons. So if you hear about beta particles, what should come to your mind is that here we look at electrons that have this symbolic representation. The usual electrons which you know, they are the ones that we call the beta particles. So still here, Unstable atoms can decompose into simpler stable atoms by emitting electrons. If you recall, for metals, like metals in group 1, sodium, lithium, and also those in group 2, during their reaction with the other substances. For example, with nanometals, for them metals, they lose electrons. So in summary, they undergo some decay process by losing electrons to form positively charged ions. So beta particles are electrons. Then for gamma rays, we basically look at electromagnetic radiations. And for them, they have this symbol. They can include television and radio waves. Those are the gamma rays. So that is the nature of these radioactive particles. Recall, we have said alpha rays, these are helium particles. And helium is an element of the periodic table. Beta rays, these are high-speeding electrons that have this symbolic representation. Gamma rays are electromagnetic radiations. You can think about radio and television waves. Next, we look at the charge. The charge of these particles. Alpha particles are helium particles. So for them, they are positively charged. For them, they are positively charged, and the unit, they are positively charged, and they have +2, positive 2 as their unit. Those are the alpha particles. Then beta particles, remember we said beta particles are electrons. Electrons are negatively charged. So they have a charge of -1 unit. Gamma rays, they are not charged. Gamma rays, radio and television waves are not charged, so they carry no charge. So alpha particles positively charged, beta particles negatively charged, gamma rays not charged. Then we look at the mass number. We can think about the masses of each of these particles. What you need to know is that when you look at the alpha particles have this symbolic representation. So they have mass number 4. Mass number is the same as the atomic mass. They have atomic mass 4. If you use the concept of the periodic table, electrons, if they have this symbolic representation, they have atomic mass 0. And the gamma rays, if they have this symbolic representation here, they have atomic mass 0. So what this should tell you is that if this has atomic mass 4, this has atomic mass 0, and also this has atomic mass 0, it implies that if we are to compare the weights of these particles, this is the weight. This is something which you shouldn't cram. This is the weight of the alpha particle. This is the weight of the beta particle. And for the gamma rays, their weight is negligible. So when you look at these values, this value for the alpha particle is higher than the value for the beta particles. It implies that alpha particles, for them, they have more weight. They are heavier as compared to beta particles. And gamma rays, for them, they carry no weight. Then we look at effect of deflection in an electric field. An electric field has a positive plate and a negative plate. It has a positive pole and negative pole. So we have said that alpha particles are positively charged. Since they are positively charged with the charge of +2, positively charged things, if you are positively charged, you are attracted by something that is negative. If you have a positive charge, you go where there is a negative. Opposite charges will attract each other. So since alpha particles have a charge of +2, they are deflected towards the negative pole. Alpha, they carry positive charge. So for them, they are deflected towards the negative pole. And for beta particles, they are negatively charged. Anything that is negative is attracted by something which is positive. So beta particles, since they are negatively charged with a charge of -1, they are deflected towards the positive pole. However, for gamma rays, they do not carry any charge. So for them, they are not deflected. Then we look at, we are going to explore each of these, some of these properties. I am going to show you illustrations on some of these complex properties so that you grasp them very well. Then we also have penetrating power. If you want to think about penetrating power, here we look at the rate at which these radiations penetrate matter. Penetrate into matter. For example, if you have a piece of paper is matter. If you have a metal sheet, it's also matter. So basically here we look at, if I have alpha particles, if I have beta particles, if I have gamma rays, how will they penetrate? Can they penetrate into a piece of paper? What is their rate of penetration into a metal sheet? Those are the things that we look at. So recall, and to understand the penetrating power, we are going to use the weight. We have seen here that alpha particles, for them, they are more heavier. Their weight is high as compared to the weight of beta particles and the weight of gamma rays. In fact, gamma rays, for them, they have negligible weight. They have no weight. So since alpha particles are more heavier, if you are heavier, if you have someone who is very fat, when the weight is high, the rate at which that person will run will be low according to the rate at which, where you have someone who is thin, who is having less weight. Someone who is thin or with the less weight, for him, as in, for that person, for him or her, there is flexibility in the rate at which he or she can run. So alpha particles, they are more heavier. Since they are more heavier, they have the least penetrating power. They move at a slow rate. However, for gamma rays for them, here we saw that they have negligible weight. They almost have zero weight. Since they have zero weight, for them, they move fast. They penetrate at a faster rate. Then the penetrating power for the beta particles, for it is moderate. So if you want to understand the penetrating power, look at the weight of these particles. Alpha particles have a higher weight. If you are fat, you will run at a slow rate. So since alpha particles are fat, they will penetrate at a slow rate. Then since gamma rays have negligible weight, almost they have zero weight, for them, they run fast. They have the highest penetrating power. Then for the beta particles, they have the moderate penetrating power. Next, we look at ionizing power. Ionizing power, here we look at the rate at which these particles can ionize, the power of their ionization, the rate at which they can be converted into ions. So for alpha particles, these have the highest ionizing power. In fact, for them, they even carry positive charge. Then for the beta particles, they have the highest ionizing power. That is alpha. Beta particles, ionizing power is moderate. And for the gamma rays that do not even have any charge. They do not have any charge. So for them, they cannot even ionize. They have the least ionizing power. Those are the gamma rays. Next, we look at effect of magnetic field. This is somehow opposite to the effect of electric field. I told you in an electric field you have a negative pole and a positive pole. For a magnetic field, you have a south pole and a north pole. So for the alpha particles for them will be deflected in the direction that shows that they carry a positive charge. That is the effect of electric field. And for beta particles, for them, they will be deflected by the magnetic field in the direction that shows that they carry a negative charge. Then gamma rays, for them, they are not deflected since they carry no charge. So allow me display these illustrations, and you are going to draw these illustrations. Let me first stop sharing this. Share these illustrations. You copy down these illustrations. You copy down these illustrations. They are going to help you understand further, grasp the concept, the content on the properties of these radioactive particles. Now, this is what we mean the effect. This is what we mean by the effect of deflection by magnetic field. This is the effect of deflection by magnetic field. So in your work, you are going to draw this diagram, but on top you put effect of, the heading is effect of deflection by magnetic field. That is the heading, effect of deflection by magnetic field. So a magnetic field, as I have told you, it has two poles, the south pole and the north pole. It has the south pole and the north pole. And here we have the source of radiation. For example, the source of radiation can be the nucleus of a heavy atom. So the nucleus of this heavy atom, if it undergoes radioactive decay, if it produces the alpha particle, the alpha particle will be deflected towards the south pole. The south pole is the direction that shows that they carry a positive charge. Then the beta particle, if they are emitted, they will be deflected towards the north pole. The north pole is the direction that shows that they carry negative charge. Then for them, the gamma rays, you are seeing the ray of gamma. For it is not bending, implying that for them, they are not deflected. However, the ray for alpha is bending towards the south pole, indicating that the south pole is where we have things that, on the south pole, things that carry positive charge go there, and on the north pole, things that carry negative charge go there. So that is for effect of magnetic fields. Let me first stop this. Next, we look at something else. Where does it go? Now here, on top, the heading should be effect of deflection by electric field. That should be the heading for this sample material. Now, in an electric field, I have told you we have a positive plate and a negative plate, positive pole and a negative pole, and this is the source of radiation. You are seeing we are having a radioactive element. A radioactive element here we mean an element which is unstable. Those elements that are unstable, that are heavy, are the ones that undergo radioactive decay. So we have in this container, we have a radioactive element. It is going to decay, and once it decays, it will produce alpha particle, beta particle, and gamma ray. So if it undergoes the decay process, you are seeing this, I don't know these colors. Girls are the ones who know colors very well. I will not tell you, I don't know which color is this, but this color, if you are seeing my pointer, this color is the one that is deflected towards the positive plate. So this color shows beta. This is the symbol of beta. It shows beta particles negatively charged. For them, they are negatively charged, hence they will go towards the positive plate. Then you also have this color that is going towards the negative plate. This color is of alpha. This symbol means alpha particles that are positively charged. So since they are positively charged, they are deflected towards the negative plate. Then this middle color shows the gamma rays. You are seeing for them, they are not taking any direction. They are passing through these plates when undeflected. They are not affected by any of the plates. So for them, they carry no charge. That's why they are not deflected. So this is the effect of electric field. You also take note of this diagram. Next. Let me hope this casting is visible. Let me try to enlarge it. Now here for this diagram, you are going to put a heading, penetrating power. The heading should be penetrating power of radiations. Penetrating power of radiations is the heading. So here, this is, for this sample material, I'm going to use it to explain the effect of penetrating power. Penetrating power, I told you, here we look at the power, the rate at which these particles penetrate through matter. So the matter which we have a paper. The paper is the first matter here. Then you have metal sheets. You have aluminum foil. Aluminum foil is here. Then we also have a sheet of lead at the end. If you recall, we saw that alpha particles, for them, they are heavy. If you are heavy, you will run at a slow rate. So since alpha particles are heavy, for them, they have least penetrating power. So for them, they stop here. They stop here, they do not continue further. If they are directed towards paper, aluminum, and lead, they will only stop at paper. Then for beta particles, this symbol is for beta. For beta particles, for them, they have moderate penetrating power. They will pass through paper. However, they will stop at aluminum foil. They will not continue further since their penetrating power is moderate. However, for gamma rays, if you recall, gamma rays, we saw that for them, they are almost weightless. They are not heavy. So for them, they will pass through paper, they will pass through aluminum, and they will also pass through lead. You are seeing they have passed through lead, so they have the highest penetrating power. As of now, I think I have explained the what? I have explained the properties of these radiations, the alpha particles, the gamma rays, and the beta particles. We have explored them, and next we shall be looking at in our next lesson, we shall be looking at effect of emission of radiations on atomic number and atomic mass. Effect of emission of radiations on atomic number and atomic mass. This will be our next plot. As of now, allow me to stop here.